I want to start with a real high-level view of what it means to mount a SQL injection attack. And we'll go into a lot of detail throughout the remainder of this course in terms of how to actually execute this attack. But let's start high level, and we're going to imagine that we have an attacker. Now this attacker wants to exploit a SQL injection risk. So they make a request, an HTTP request, a very carefully crafted HTTP request. And of course that request goes to a web server. Now that web server receives the request to the web page, and the web server constructs a query out of that request. So think about the typical things that a web application might want to query an underlying database on. This is the query that's being constructed in the injection attack. Now very often there will be a firewall sitting somewhere between that web application and the database. But in a SQL injection attack, it is still the web application talking to the database. It's not like the attack is going direct to the database. And this is one of the things that makes the attacks so successful, because it's still just website and database talking. So the query goes through the firewall and then all the way down to the database. The query executes in the database and the database returns some data. Back out through the firewall, back to the website, and eventually back to the user. This request and response lifecycle is very, very typical, and it's exactly what happens when someone's just browsing around on the website. But in this case, the request is very carefully crafted to be malicious, to execute an attack within the database, so it becomes a very specially crafted query, and then return data which the application didn't intend to be returned back out via the HTML response to the attacker. Now here's where it gets kind of interesting with an injection attack. When the web application talks to the database, it must authenticate. So the web application has database credentials stored in it that it uses to identify itself when it goes to the database. And much of the discussion around SQL injection is what is that web application actually allowed to do? What data can it read or write? What commands can it execute on the database server? And the thing is, that website is almost always going to connect to the database using the same identity, regardless of who the actual user is. It doesn't matter whether they're Bob or Jane, anonymous or authenticated. The web application almost always connects under the same identity to the database. And certainly many SQL injection risks occur because the credentials that that web application is using have access to do malicious things on the database. It's excessive access rights, but it happens all the time. And we're going to look at what can happen when those access rights are excessive. And later on in the course, we'll also have a look at what you should do to constrain those access rights. Now, one other thing while we're on this slide, you can have different types of web application, different technology stacks. They could be ASP.NET, PHP, Java, different databases. So for example, SQL Server or MySQL or even Oracle. You have lots of different technologies that can make up this very generic picture that we see here. And the way the attack is mounted against those different technologies is different. So for example, there are language semantics between a database server like SQL Server and MySQL, which mean your query needs to be different. So if you're trying to mount a SQL injection attack against the database, you need to know how to query it. And it's going to change depending on the site and the technology stack they've chosen. So whilst we talk about this very generically here, the actual execution of the attack is going to change site by site. Now, fortunately, you'll also find that newer versions of technology are getting better at defending against these SQL injection attacks. So for example, we're going to look at an ASP.NET application during this course. And If you were to build an ASP.NET website today, you'd use technologies that implicitly make injection attacks very hard. You can certainly still find injection risks in these applications, but it is much more about falling into the pit of success from the perspective of the application owner. It's the old stuff that tends to have so many vulnerabilities. So go back to things like classic ASP. So whenever you see a .asp extension in the URL, that's the sort of stuff where injection attacks are rampant. So there are a number of different factors that go into the prevalence of the attack and how the attack is actually executed. But before we go on and actually start practicing some attacks, I want to talk about the impact. So what does it really mean when a SQL injection attack is successful? Let's go and have a look at that now.